Okay guys, so we are about to start our next unit, and that unit is exponents. So to remind ourselves what an exponent is, if you see something like 5 to the third power, that really means 5 times 5 times 5. So the answer to 5 to the third power is really 125. And it works for variables too. If we say x to the second power, that is x times x. So we need to know that knowledge going forward as we dive into some more tricky problems. And let's start with some vocabulary. So if you are shown something that looks like 6x to the fourth power, there are 3 different pieces here. The 6 is called the coefficient. Just like when we had 6x, we still call 6 the coefficient. X here is the base. It is what we are actually raising to the fourth power. And then 4 is known as our exponent. So what this means is we want 6 x to the fourths. So we're going to find x to the fourth and do it 6 times. So knowing that information now, we're going to start studying some of the rules and laws that go along with exponents. All right, so everyone should already have this paper. If you don't have it, you can print a copy off of Blackboard. And your job is going to be to follow along with this video and complete the paper so that you have it ready to turn in next time you go to algebra. So what this paper is covering is we're going to go through all the different rules and laws of exponents, and we're going to try and come up with those rules on our own by looking for patterns as we go through different examples. So the first section has 2 different exponents being added. If you notice, the base is the same. They're both a cubed, but they have different coefficients. So what this really means is we have a cubed plus a cubed, because that's 2a cubed, plus a cubed plus a cubed plus a cubed plus a cubed, and that's 4a cubed. So you can see we have a total of 1, 2, 3, 4, 5, 6 a cubes. So our simplified expression would be 6a cubed. You guys have been doing this in September, so hopefully this isn't too scary for you. So let's look at the next one. 3x squared minus x squared. That's x squared plus x squared plus x squared minus x squared. So you can see we have 3 of them and we're taking away 1. We are left with 2x squared. So this would be a really good time to pause the video and see if you can complete the last example on your own. So for the last one, you should have gotten AB plus AB plus AB plus AB plus negative AB plus negative AB. So we had 4 ABs and we added negative 2 ABs. That left us with 2AB. So the general rule, if the bases are the same, you can add or subtract the coefficients. Remember, we talked about what bases and coefficients are. So basically we're saying, do we have the same base and exponent, okay? Okay, so let's move on to the second section. And this is when we are multiplying exponential expressions together. So the first one says 2 to the fourth times 2 to the third power. This is really 2 times 2 times 2 times 2. That's 2 to the fourth times 2 times 2 times 2. So we end up with 7 2's being multiplied together. This is equivalent to 2 to the 7th. And I know that you can put 2 to the 7th into your calculator and get an answer, but we're not concerned with that right now. All we're worried about is leaving it as a simplified exponential expression. So the next one would be 3 to the first, that's just 3, times 3 times 3 times 3 times 3. So 3 multiplied by 3 to the fourth, we end up with 3 to the fifth. This would be a good time to pause the video and see if you can do the next one by yourself. So the next example would be m, 5 of them, times 1, 2, 3, 4, 5, 6, 7. Lots of m's. When I count them all up, I end up with m to the 12th. So the next one's a little bit tricky because it has a coefficient in front of each one. And I'm going to suggest that we leave the coefficient out front. So you have 3 times x times x. That's the same as 3x squared. 4x cubed is 4 times x times x times x. So we end up with 1, 2, 3, 4, 5 x's. And we also have this 3 times 4 out front. So we're going to write it as 12x to the fifth. So this next one is a generalization. It's trying to figure out a rule that is good no matter what a or b is. No matter what exponents you have, what could you simplify the rule down to? So this is really x to the a times x to the b. There's no way to simplify that at all. Can you guys see a pattern? What happened? When we had 4 and 3, how did we get to 7? When we had 1 and 4, how did we get to 5? Hopefully you guys can see that you add the exponents. So if I'm multiplying these, it turns out to be x to the a plus b. If there is a coefficient, then we're going to multiply the coefficients together, and then we're going to add the exponents. So it becomes 5 times 2 is 10 y to the a plus b. So our general rule here becomes multiply the coefficients, add the exponents. And this only works if the base is the same. We're only adding the exponents if they're both x, or if the base is both x or both y. All right, so now we know how to add expressions with exponents. We know how to multiply expressions with exponents. We're going to go one step further, and we're going to raise an exponent to another exponent. And this looks really complicated, but if we break it down, it's very manageable. So let's do exactly what we did up above. If we say that we're raising 2 squared to the third power, that's really 2 squared times 2 squared times 2 squared. Okay, because we have to do it 3 times, so 2 squared, 2 squared, 2 squared. And that, based on what we just did before, is really 2 times 2 times 2 times 2 times 2 times 2. So you can see, using the rule we did above, 2 times 2 times 2 times 2 times 2 times 2, that's really 2 to the 6th power. See if you can do the next two. See if you can do 3 to the 4th quantity squared and x to the 10th quantity squared on your own. then come back to the video. Okay, so 3 to the 4th squared is really 3 to the 4th times 3 to the 4th, which is the same as 3 times 3 times 3 times 3 multiplied by 3 times 3 times 3 times 3, or 3 to the 8th power. X to the 10th squared is really x to the 10th times x to the 10th. And we could write out all those zillions of x's, but hopefully by now you've realized that there is a shortcut. And it would be a lot faster to just add those exponents. So we can call this x to the 20th. Okay. Now the next couple are a little trickier because there is a coefficient in that expression. So we are cubing 2x to the 4th times 2x to the 4th times 2x to the 4th. So when I write this out, I'm going to make sure that that 2 shows up in each of the parentheses. So what this really means is we're doing 2 times 2 times 2, x to the 4th, x to the 4th, x to the 4th, because the commutative property says I can do it in any order I choose. So this becomes 2 times 2 times 2, x to the 4th, x to the 4th, x to the 4th, or 2 cubed x to the 12th. And I know that you could write 2 cubed as 8, but for our purposes, we're going to leave it as an exponent for now. So go ahead, you try the next one. See if you can write it out, and then come back to the video and see if your answer matches. When you do this, you should get 3x cubed times 3x cubed. You can simplify this out to be 3 times 3 times x cubed times x cubed. And again, we could write out all those x's, but I think it's faster to just call this 3 squared x to the 6th. So a generalized rule for this, you can hopefully see what we're doing is we're multiplying these exponents. And when we had x to the 10th squared, it became x to the 20th because 10 times 2 is 20. 3 to the 4th squared became 3 to the 8th because 4 times 2 is 8. So x to the a raised to the b power is going to be x to the a times b. And our generalized rule is going to be multiply each exponent.